Yeah, that's cool. Well, that's good. I'm glad to see you there. Come on. Okay. I don't know if the screen is actually working. This app sucks. Let me just make sure that's actually running. And then we'll start. Okay, it appears that the stream is working. We will see if that continues. So welcome back. Do you guys do anything good for Thanksgiving? No? Oh well. You didn't travel or anything? No. How boring. I went to California. I drove out there with my wife and dog. Saw some family. Uh-huh. Yep. Did it in one sitting, too. 22 hours each way. Yeah, so we just do it straight through. We're kind of used to it. We've been doing it for a long time. But yeah, it's kind of a pain. That's it. Wasn't too exciting. We really don't have anything really left to cover that's really new. The only thing left is, what chapter is it? 8.6? 8.7? 8.7, which is identity. So, one of the powerful things about this version of logic, predicate logic, is that it allows you to say more than just these things have these properties, but also that this object or this entity equals another entity, right? And I've already introduced that, so it's really not new. Again, if x is the same as y, and if x has property p, then y has to also have property p, right? So if I made an argument like this, premise 1, x is the same thing as y, x is property p, I can conclude y has property p, right? Okay, that's 8.7. Treat this as its own proposition, right? That's a well-formed formula now, x equals y. This is also a well-formed formula. What's that saying? X doesn't equal y? They're not the same, right? Another way to write that would just be to negate x equals y. That looks like a 2. That's a negation. You just negate x equals y. I'm not really even sure why they use that, but whatever.
So you were to have x does not equal y, say x were to have a property, does this mean that y cannot have that property?
No. Are we the same?
No.
Are we both men? Both American?
Yes.
Yeah. Makes sense? So yeah, you can't say just because they're not the same, they don't have the same property. But philosophically, we do tend to think that if two things are distinct, there's going to be at least one property that they do not have. There's going to be something unique about them, right? And philosophically, we tend to think if two things are the same, they're all going to have identical properties, right? There's some really technical stuff why those might not be true, but I'm not qualified to talk about them, and I don't really give a shit about them either. It's just a sort of hair splitting that philosophers sometimes do that I'm not interested in. Does this make sense? Okay. So, really, there's nothing to really teach you about this. I mean, if we're treating these as entire propositions, right, then our rules just apply to them. So let's say I have x equals y. If x equals y, then let's say y has property p. What can I conclude from that? Or y has property p, yeah. Now we can also conclude something else about x too. But I could just do a straight up 1-2 modus ponens on that. Does that make sense? And then now, because I also know that x equals y, I could use the law of identity to, again, whenever two things are really the same, they share all the same properties, I can also conclude from that x has property p, right? But the point of showing you this is just that this is a whole well-formed formula. It's a proposition, so you can just use it like a proposition. Just use your rules on it, right? Make sense? Okay, so that's the end of the semester. I don't think I'm overlooking anything. Yep, that's pretty much it. There's 8.7. We're done for the semester. What I want to do, if you guys want to, there's only 2 people here for everybody watching. I would like to practice this a little bit because it does have some interesting implications. Like, this is really helpful on a philosophical or logical level. Having identity helps us disambiguate some important things. So I'd kind of like to practice 8.7. Are you guys down to do that? Okay, so if you got your book, turn to 8.7, and let's turn to page, if you got the 13th edition, let's turn to page 528. I wish I had a place to set my book down. I guess I could use the lectern, but I'm too lazy to move it. Turn to page 528 in the 13th edition, and we're going to talk about definite descriptions and practice with those real quick. So, what a definite description is it's a definition, or it's a way of pointing to or referencing a particular object without naming it. Right? So, if you wanted to give a definite description of me, you could say something like the 6'2", 250-pound man in a vest standing in front of classroom 203 at Oklahoma State University at approximately 10:45 a.m. today, right? And that would single out one person, right? Me. No one else, just me. So you just pointed to me, you referenced me, you described me and said, I'm talking about that guy over there without naming me. Now it's easier to name me, right? Pierce. But philosophically, sometimes we can't just name objects. We want to understand what an object is or what object we're talking about by listing its attributes, by listing its properties, by describing it, right? So the example the book gives of a definite description, let's see. Okay, here's an example from the book that I think is not that confusing. If I want to say that, and this might involve a name, but it doesn't have to, the painter of Starry Night. The painter of Starry Night. How could I say that in logic? How could I essentially name him without naming him? Without treating him as a subject, the little letter? We all know who painted Starry Night, right? Van Gogh. Okay, so how can I reference Van Gogh without explicitly saying Van Gogh? Is there a way anybody could think of doing it? Is there a way to list some of his properties such that there's only really one person or one entity that could fulfill that description? Okay, let's take the painting Starry Night. We'll say it's a little S, right? We'll take V for Van Gogh, even though I'm going to try not to use it. And I want to reference Van Gogh. I want to say, let's say there is a painter of Starry Night. Let's actually say there is only one painter of Starry Night. Right? It's just Van Gogh. But I want to talk about there being only one without talking about Van Gogh. What I can say is that there exists an X such that what?
Can I use a proposition instead of a subject?
Say that again?
Can I use a proposition instead of a subject?
Instead of a subject, what do you mean by that?
I say X, and then or PX, and then P has the quality of painted Starry Night.
Okay, so you're thinking that PX would be X painted Starry Night, right? I would just put that as a relation. X painted the particular painting Starry Night. Does that make sense?
Would
Yeah.
both work?
What?
Would both work?
Yeah, both would technically work. Yeah, yeah. Again, there's that ambiguity where there's no real rules on how you divide up properties and relations from entities, right? So there exists an X such that X painted Starry Night. What else could we say? If I want to now say there's only one of them, which I guess we could say this is definite description with numerical identity or number. Think about what this is saying. There's only one painter of Starry Night. Does that mean there's two painters of Starry Night? Does that mean there exists two painters of Starry Night? Does it mean that, does it rule out that there can't be two painters of Starry Night? Right? If there's only one painter of Starry Night, there can't be two, right? So it rules that out. Okay, so there exists an X that painted Starry Night. Does that tell you there's only one? No, it just says there is at least one painter of Starry Night. Well, maybe there's multiple X's, right? So how do we essentially close off the possibility that there's more than one X that fits this? Think in English. You just say, and there's only one, right? How would I say, and there's only one? I don't have a sign for number. I could give it a proposition, only one. But that's cheap, right? That doesn't really capture what we're trying to do. The other thing we could do is we could say that and for any y, for anything y, if y painted Starry Night, then what? Then x equals y. Okay, so parse this now, one of you. What's this say? Someone read this for me out loud.
There exists an X such that X painted Starry Night, and for all Y, if Y painted Starry Night, then X equals Y.
Good. So now let me ask you, if I were to say, well, there's actually two things, there's X and Y, and they both paint Starry Night, is that compatible with this?
Say that again.
So if I say there are two things, and they're distinct, X and Y, they're two different things, and they both painted Starry Night, could I say that and this at the same time? No, why? That's saying there's two, that's captioned in English. But what this part does is it tells me that anything Y, anything, if I ever am tempted to say there's another painter, there's another thing that painted it, I have to say that that other thing is really just the same as this first thing. And that's how you express there's only one, right? And this is clearly a way of talking about Van Gogh, right? So, whereas I could say, I could just talk about Van Gogh, I could also talk about the one and only painter of Starry Night, right? And that's how I'd express it here. There is a painter of Starry Night, and he's the only one, because everything else that exists that painted Starry Night is really just him, right? So the interesting thing about identity isn't that it changes our way of doing proofs, or we need new rules. I mean, we have the new identity rule, but it's obvious, right? The interesting thing about identity is that it allows us to very precisely talk about people and also number things, right? So let's look at, again, let's look at a numerical statement, a different one. We'll say, again from the book, there is only one God. How could I say this? There's only one God. It will be similar to this. If I say there's only one God, does that mean God exists? There is only one God.
Would you not use the EX? Would you say that for any X, X is G, and for any Y, if Y is G, then X is Y?
Okay, so let's try that and see if it works. So say that one more time for any X.
So for any X, X is G.
If X is God.
And for any Y, oh no conditional, just the, I guess and. Would those two just be separate or separate?
Well, this would say for any X, X is God.
Yes.
That means you're God, I'm God, that's God, that, right? Yeah, so I think it would have to be a conditional.
Okay.
So you'd be saying for any X, if X is God, then for any Y,
if y is God, then x equals what?
If y is God, then x equals y. Good. So this says for any x, if x is God, then for anything else that's also God, it has to be the same x. So there's only one God, right? Nothing else but this original x can be God. But does this say there exists a God? No, it's purely hypothetical, right? If for any x was God, that doesn't mean God exists. It's just saying, this right here says, if God existed, he would be one, right? If God exists, there's only one of him, or if God existed, he would be one, etc., however you want to say it, right? Or I think the book puts it, there is at most one God, right? There is at most one God. It doesn't say there's even one God, it just says at most there's only one, right? So how can I say there is only one God? And say God exists and he is one. And there's only one of them.
Instead of just regular x, would you say dx?
So there exists an x such that x is God.
And then just copy paste everything else?
Well, might not work. Let's try it. What's this say now?
There exists an x such that x is God, and if x is God, then for any y, if y is God, then x equals y.
Close. Your reading is what you're supposed to say, but you're actually not reading the conditional. So there exists an x such that if x is God, then for any y, if y was God, then x equals y. It still doesn't say that there exists an x that's God. It just says there exists something that if it was God, then the rest would follow, right? So we'd have to change, and this is kind of the tip I gave a long time ago. Typically, universal statements will have a conditional, and existential statements will have an and, or an or. So this now says what? What's this say?
Saying that there exists an x such that x is God, and for all y, if y is God, then x.
Good. Beautiful. I like it. Okay. So now that says there's only one God. This says if there was a God, there'd only be one of them. Right? So the importance of identity and is that just by introducing this and this, those two ways of doing multiple formulas, we can now number things. We can say there's this many of this thing, or there's not any more than this number of this thing, right? And then we can also, so these allow us to talk about quantity, but it also allows us to pick out particular people or objects, particulars, without treating them as subjects, right? Which are small letters, like A, small a, right? Makes sense? Because here I just talked about God. God's a person, right? If he exists, God's a thing that exists, in a sense. I have not even given a single subject here, a small capital letter G. I've talked about God without having to do that, right? Okay. Questions? let's just do some of the homework problems. We'll start with definite descriptions and numerical identity, and then if we have time, I'll talk about the other use of this, which is superlatives. Superlative is a stupid fancy grammatical word for ways that we talk about how I'm bigger than you, right? So it's like, I am bigger than you, and if I wanted to say nothing is bigger than me, I would use identity to say that, something like, I am bigger than you, and no one else in the room is bigger than me. I'd have to use identity to do that, but we'll get into that later. Maybe Thursday, maybe at the end of the class. So let's do 8.7.1, and we'll go skip to number 20. So 20 says, there is at most one city in Belize. All right, what's that mean? There's at most one city in Belize. Does it mean that there is a city in Belize? No. I mean, obviously we know. Oh, wait, is Belize a city or a country? I'm an idiot, huh? There's at most one city in Belize. It doesn't necessarily mean that there's even any cities in Belize. So how could I say this? How could I say this in our logic?
Would be universal.
Mm-hmm. Any other thoughts after that? It would be universal, that's correct. So let's just say that says X is a city. This says X is in Belize. How can I start to implement these? There is at most one city in Belize. For any X, if what?
X is a city and X is a Belize.
Yeah, for any X, if X is a city in Belize, then
For all Y.
for all Y,
If Y is a city and Y is in Belize, then X equals Y.
good. For any X, if X is a city in Belize, then for any Y that's also a city in Belize, well, X has to be Y, or Y has to be X, whatever you want to say. Yeah, there's only one. Does that mean there's a city in Belize? No. Now, if I want to say there is one city in Belize, and only one city and beliefs. How would I say that?
EX, CX, and DX.
Good. So that says there exists an X as a city and beliefs.
And then, not conditional. Then copy paste starting at Y.
Good. And for any Y that's also a city and beliefs, then X must be the same as Y. Good. Beautiful. Another way to write this would be there exists an X such that X is city and believes, and there is no Y such that Y is a city and believes, and X does not equal Y. Right? Why are these the same? Change a quantifier rule. Yeah. Where does that negation go? If I was going to change a quantifier, I have to put a negation on both sides, right? Well, it goes in here, does a bunch of De Morgan stuff. It changes the conditional to an and, but then it ends up negating this. When I put the slash through the equals, it's just a negation of X equals Y, right? So yeah, just change a quantifier. But again, if the kind of universal way of talking doesn't appeal to you, if you think more in concrete terms like I do, you might be more prone to saying something like, look, there is a city in Belize, and there doesn't exist, there's no such thing as a city in Belize that's not that same city. These are the exact same things. Okay, let's do... Any questions before we move on to another one? Okay. Let's do... $23. There are at most 2 cities in Malta. Again, X is city, X is in Malta. That's what we're given. And then I'll also have the other version. There are 2 and only 2 cities in Malta. Let's figure out how to say these, although it's starting to get quickly more complicated. As we, instead of saying 1 and only 1, we're now saying 2. How do we do 2? Here's a hint. If I say there is something X, and there is something Y, and there is something Z, right? Did I just say there are 3 things? No. Why? Because each of these only says there is at least one, right? So let's say I say there's one city. There is a city, there is a city, there is a city. I just say it in 3 different ways with different variables. Sorry, those should be Z and Y. It doesn't mean there's more than one city. There might be 1 city, there might be 3 cities, there might be 10 cities, there might be 1,000 cities, right? All of these individually just say there's at least one. Maybe there's only one. How can I say that there's 2 of them? Well, I could say there exists an X that's a city, and there exists a Y that's a city, and X doesn't equal y. What does that say? If we group it like that. Yeah. What does that say?
There are two cities, they're not the same. They're different.
Close. Again, there's at least one city, and there's at least this city, but it doesn't say that they're different or the same, right? It doesn't say two, it just says there's at least one thing that's a city, and there's at least one thing that's a city. But, or and, that city don't equal that city. Well, if X and Y are cities, but they don't equal each other, then how many cities do I have? At least two, maybe more, but I know I have at least two, right? And then if I bring in, let's say I bring in Z here, and I said there exists a Z, such that Z is a city, and I'm running out of room, that looks like an E. And now let's say that X doesn't equal Y, doesn't equal Z. And I start stringing together the identity symbol. If you can't see it well, I just did that. That's a proposition too. What's that say? X, Y, and Z aren't the same as each other. Yeah. You can't reduce Y to X, X to Y, Z to Y, Z to X, right? They're three different things. So this now says, look, there's at least one city, and there's at least one city, and there's at least one city, and these two cities aren't the same, and actually in reality, all three of them are distinct from each other. So now I know that I have at least three cities. Okay, so you see how it's starting to work. As you get more comfortable with it and you start figuring out how to use identity, you can say really complicated shit. Just like when I say 2 plus 2 equals 4 equals 8 divided by 2. Right? Yeah. That's 4, and that's 4, and that's 4, right? So in math, I could use the equal sign to link multiple things to one another. Well, I could also do the same in math or in this logic with, let's say 2 plus 2 does not equal 5 and does not equal 10, right? That makes sense, they're all different numbers. That's all we're saying. Well, but with that equal sign, what you're starting to get into is you could very quickly start adapting predicate logic into a mathematical calculus. And the old-fashioned goal that people had was if you got predicate logic precise enough with identity, and then also introduce stuff with set theory, like, have you guys ever done set theory? Have you ever heard of sets, like in math? Or groups? Like, so it's like, I don't know, you have the set of all OSU students, which is like 14,000, I think now. And then within that set, you have, let's say, the students who get A's, the students who get B's, the students who have C's, so you have like groups, right? That's all sets are. Sets are just groups of things. And there's a whole logic governing sets, so that like, well, if I'm a member of this set, then I'm also going to be a member of that set, right? If I'm a member of OSU students who get A's, then I also have to be a member of the set of OSU students, right? The old-fashioned hope was that if you could get set theory nailed down, you can incorporate set theory and identity or equality into predicate logic, and suddenly now you have a mathematical language or a symbolic language that covers everything. Math, common speech and reasoning, I mean, those are the only two things, right? Just everything. It covers the whole world. So, if this actually pans out, which I don't know if it actually does, I don't really care that much, you're learning a universal language that might be able to model and capture all human thought. Mathematical and, normally logical. I don't know if it works and I don't really care. Okay, anyway. So let's get back to these. Let's say first there are 2 and only 2 cities in Malta. How can I say that? There are 2 cities. That means there exists the cities, right? So we know we're going to have existential. But how can I say that more fully? So there exists an X, there exists a Y. I'm just going to stack them like that for now, but again, remember we can kind of change how they're spread out too. Exists an X, exists a Y, such that
X is a city, X is a Malta, and Y is a city, and Y is a Malta.
good. Now again, that does not say that there are 2 different cities. It just says there's at least one thing that's city in Malta, there's at least one thing that's city in Malta. Maybe they're identical. How do we start to differentiate them?
You could say for any Z or universal.
I'm writing an E for some reason. For any Z, Z city in Malta.
Z equals Y. Could be and or. Z equals X.
If it was and, you'd be saying that Z equals Y and Z equals X, which means, well, then all of the cities just reduce to Z, right? So there's only one. So it would be or. Z equals Y or Z equals X. Right? Now what that's saying right there, put an and here, is for any city in Malta, if it's a city in Malta, I'm sorry, for any Z, if it's a city in Malta, then Z is either going to equal Y or X. And we know that Y or X are cities in Malta. Okay, but the problem is there's a possibility still that Y and X are the same. We didn't rule out. Does that make sense? So this still actually only ends up saying there are, well, what would it be? For any Z, it is equal to Y or X. It'd be basically saying there's at most 1 or maybe 2. Okay, this is saying there might be 2. Might be. But it's not saying there are 2 and only 2. Right? How can I narrow it down further to say that these 2 are distinct?
X doesn't equal Y.
And X does not equal Y. Just add that on. Now I've got a big string. So I might want to rewrite this to kind of organize a little bit better, make it more clear. But if I add that on, what this says is, look, there's at least one city in Malta, there's at least one city in Malta Y. There's at least one city in Malta X, there's at least one city in Malta Y, and they don't equal each other. I know I have 2 now. Right? I know I have 2. And for any Z, if Z is a city in Malta, then it has to be one of these 2. So let me rewrite this more in order. There exists an X, there exists a Y, such that X is city in Malta, and y is a city in Malta, and x doesn't equal y. Now again, that tells me I have at least 2 cities in Malta. And for any z, which now I need to do the big bracket, for any z, if z is a city in Malta, then z either equals y or z either equals x. There you go. That's a long proposition. That's a long way to say there are 2 and only 2 cities in Malta. Makes sense? Tedious. Very tedious. Alright, let's look at, there are at most 2 cities in Malta. Again, the difference here is that when I say there are at most, that doesn't mean I'm committed to saying there's even one of them. So there are at most 2 cities in Malta. I'll tell you right off the bat, we're going to have universals. What do I do from there? For any x and for any y, if what? Good. Perfect. A lot of brackets there. Good. Read that top one to me now.
For x and for any y, x is a city, x is in Malta, and y is a city, y is in Malta. Then for any z, if z is a city and z is in Malta, then, sorry, if z is a city and z is in Malta, then, sorry, it's...
And that's z equals y or z equals x.
Then z equals y or z equals x.
Yeah, good. So now notice that we don't have anything saying these 2 cities are distinct. Why? There's at most. Good, yeah. So that means there could only be one. Maybe there's none. Whereas this is saying there are 2 distinct cities and only 2.
Sorry, you just told it to me, I'm sorry. So the last part, does it say z equals y and?
Z equals y or z equals x. Yeah.
Sorry.
No, you're good. Okay, is this kind of making sense? I know it's complicated. The proofs will remain the same, though. The interesting thing is the translations. Because, I mean, yeah, this is complicated and long and confusing, and I hate looking at it. But all you have to do to start working with it is do your instantiation generalization rules, and you'll be fine. Let's do one definite description, and then we will go back to We'll go back to superlatives.
I think definite descriptions are actually just what we did, except the thing that we were saying without saying is just the number 1 and 2.
Yeah. So really all a definite description is picking out a particular thing, right? So when we talked about Van Gogh, or when we were indirectly talking about Van Gogh, right? The painter of Starry Night, the painter of Starry Night, the one and only painter of Starry Night, I'm picking him out without naming him Van Gogh, right? It's the same if we were talking about these 2 cities in Malta. We'd be saying, look, there are 2 cities in Malta, and I am picking them out as the 2 and only 2 cities in Malta, right? So yeah, they are still definite descriptions. I'm not sure why the book divides them as if they're 2 separate categories, but you're right, they are fulfilling the same function. Let's do... What do I want to do? I don't like these.
The book gives a very different answer than what we just did.
What'd you say?
The book gives a very different answer than what we just did.
What's it say? Let's take a look at
3, it says universal X, Y, Z. This is a lot. I don't know if you're going to want to write it.
Okay, I'll just take a look at the back. 8.7.
Then bracket, parentheses, CX and MX and CY and MY and CZ and NZ, close parentheses, additional open parentheses, X equals Y or X equals Z or Y equals Z, close parentheses.
So, that's the same thing. One difference there is that to try to cut down on the clutter, they've moved all the quantifiers to the left outside. So you've got X, Y, and Z on the outside like this. But they've also betrayed their own rules by, if you look on 23, 8.7, the answers, they just have CX, MX, CY, MY all strung together. But, well, that's not well formed, right? There's no middle. So, I mean, you get to a certain point, and with ands and ors, you're just like, I'm done using the parentheses, because as you saw how cluttered those were, you have to group them up really carefully, right? So that gives it a very different look. Then the last part of X equals Y or X equals Z or Y equals Z, that's just saying that, look, there's 3 possibilities and none of them are exclusive. 2 of these cities reduce to one another so that there's 2 cities. Or 2 of these cities reduce to one another so that those 2 cities are one and this city is one, so you still got 2. Or they all 3 reduce to each other and there's 1, or none of them reduce to each other because there are none, so there's 0. Same thing. Does that make sense? If you look in the back of the book, some of the answers they give, they look less cluttered and convoluted, but in my opinion, they're even
Well,
worse.
so let's say, like, yours made sense when you just, on the board, what we just did. That one is just...
Yeah, you just really have to disentangle what they're saying. Because, yeah, I mean, for anyone watching at home, they literally just do this. Which, again, that's fine. Like, the parentheses order doesn't matter with ands or ors, right? But this entire class, this entire book has been telling you, you have to have a middle upper in it. And that doesn't have a middle. Okay, so let's just go with, this one is going to be 8.7.1, number 30. I'm going to modify it a little bit. We'll start with the author of Vanity Fair. Now I could treat, in India, I can treat the author of Vanity Fair as a particular person or name, right? So I could just go, well, I'm just going to say A, the author of Vanity Fair. That's fine. But if I want to give a definite description where I pick out or reference this person, this single author, without treating them as a subject, how can I just kind of describe them well enough to pick them out individually? Again, when I say the author, that means one. The author. So if I say the author, how can I start naming that person? If I say the author of Vanity Fair, does that mean they exist? If I say the dog in the other room, that implies that there's dog in the other room, right? Now maybe I'm wrong, but I'm at least intending to tell you there's dog in the other room. So the author of Vanity Fair means they exist. So we'll say there exists an X. Now how do I describe that vague X in such a way to pick out the author of Vanity Fair? The author of Vanity Fair. So there exists an X such that X is what? The author of Vanity Fair. How do I symbolize is the author of Vanity Fair? Is that a property or person? It's both in a sense. But let's treat it as a property. How can I symbolize this being the author of Vanity Fair as a property? How would I say that? Oh, that's another option, yeah. So we can either go X is the author of Vanity Fair, or even better, little v equals Vanity Fair, right? That publication. X is the author of Vanity Fair. So this says what right here? Right. There's at least one. So does that tell you there's only one? That tells you there's at least one, maybe there's more. How do I now say the author, which implies there is only one? There exists an X as the author of Vanity Fair, and yeah. Beautiful. Nice. Good. There's one and only one. Okay. Now, if I wanted to start saying a bunch of shit about the author of Vanity Fair, say that the author of Vanity Fair is an idiot, and let's say X is an idiot is just IX. I don't have to know who this is. I don't have to name them. I could say, look, there exists an X, such that X is the author of Vanity Fair, and I'm talking about one person. And that person's an idiot. Right? Or I could be a normal human being, well, semi-normal because I'm still doing logic, and I could just say, look, this is the author of Vanity Fair, and the author of Vanity Fair is an idiot. And maybe I could even add something in that if something Y wrote Vanity Fair, then Y equals A. That particular person, right? Isn't that much nicer than this? I mean, it's not nice, I'm still calling them an idiot, but you get what I'm saying, it's concise, right? But again, the purpose of a definite description, at least one of the purposes, is that we don't have to name them as a subject. Okay, the author of Vanity Fair was born in India. Again, now how do I start saying this? The author means they exist. It means there's only one of them. So how did I do that a second ago? The author of Vanity Fair. So there exists an X such that
the book gives you W, X, Y, Z, X for Y. That's basically what we're doing with the word, with the letter A.
which would be
EX.
wrote. Yeah, okay. Cool. So I'm gonna stick with A for author. But
EX, then A, XV, and
EX, then AXV,
and bring Y, A, YV, then Y equals X. So that first establishes that there's an author. Now, would you do a second line, or would you have to keep it all in one line?
it was like a second proposition?
Yeah.
No, you keep it all in one. Yeah. That's an interesting question, though, because it almost sounds like I know there's an author of Vanity Fair, premise one. Premise two, that person was born in India, therefore it follows the author of Vanity Fair is born in India. The problem is, if I wanted to, without naming that particular person with a little a or something, I'd have to just remake this all over again, because if I just said X was born in India, I don't have any reference now. I don't have any particular person I'm referencing saying they're born in India. The thing about whenever you have a word, or let's say a way of naming something, that picks out or references an object. Not all words do that, but names and stuff like that do.
You might hate me for this question, but could you say parenthesis all of that and say all of that equals Z, and then next line Z was born in India?
All of this equals Z?
All of that, yes.
How would I say all of this equals Z?
Equals Z. Or can you do that?
You can't do that, no. Because that doesn't make sense, right? This entire proposition equals Z?
Yes.
I guess you could, at the level of propositions you could, but then you're not talking about the person, you're talking about this entire proposition equals Z. Interesting though, because you can, look, you can talk about propositions. You could make propositions about propositions. Let's say I have the proposition God exists, right? That's a proposition. Well, then I can say God exists, that proposition is true. Well, that's a proposition about a proposition, like what you just did, right?
It was worth a shot.
It was worth a shot. It's interesting.
Okay, well then I guess you would continue through a series of brackets and parentheses and such. Would you say like if X was the author of Vanity Fair, then X was born in India?
You could. I think it's overcomplicating a little bit. You might be overthinking it.
Or would you just say X was born in India?
Yeah. There exists an X such that, now read it.
There exists an X such that X authored Vanity Fair and pretty Y. If Y authored Vanity Fair, then Y equals X, and X is born in India.
Beautiful. Good. So in normal person talk, there's an author of Vanity Fair and there's only one of them. There's the author of Vanity Fair. And they're born in India. Now again, simple way to say this. I just name the author of Vanity Fair and I say that that person was born in India. Right? Okay. What time is it?
37.
What'd you say?
37.
37? Let's just do this. I'm just going to give you a quick example, and then we'll go. The largest planet of Jupiter. This is called a superlative. Superlatives are, again, just ways of saying this is the biggest, this is the most, the thing that has the most of this property out of anything else. There's none that compares to it, right? The largest planet that exists is Jupiter. At least in our solar system. So let's just pretend like our solar system's all that exists. How can I say the largest planet is Jupiter? And let's just say we don't have to do a definite description. We can use J for Jupiter. Because we're not overcomplicating things to the definite descriptions. Say X is a planet. Let's say X is larger than Y. And we've got Jupiter here. I'll throw this at you, and then we'll end. For any Y, if Y is a planet, then Jupiter is larger than Y. Is that right? Think through the implications of this. For anything that exists, if it's a planet, then Jupiter is larger than it. Is Jupiter a planet?
Strictly, wait, yes.
Yeah. Jupiter is a planet. So, if Jupiter is a planet, but for anything that's a planet, Jupiter is larger than it, then it follows that Jupiter is larger than itself. Does that make any sense? I guess it makes sense, but it's not true. Something can't be bigger than itself at the same time, right? So that's not technically correct, but it's close. For any Y such that if Y is a planet, how can I prevent us from talking about Jupiter? All planets other than Jupiter. So for any Y, if Y is a planet, and how do I say Y isn't the same as Jupiter? Y is not equal to Jupiter. Then what follows from that?
Like you had earlier,
Jupiter is larger than Y. Yeah. So again, with superlatives, you say things like that. For any Y that's a planet and it's not Jupiter, then Jupiter is bigger than it. That's how you say Jupiter is the largest planet. Right. If you didn't include the identity part, then you'd be left saying things like Jupiter is larger than Jupiter, which is just stupid, right? So that's how you do superlative. Okay, questions, anything? All right, that's it. Friday or Thursday, you do not have to come. We are done. If you'd like to come and practice or review, I will be here, but you do not have to show up if you don't want to. The rest of the class is already checked out. You guys can check out too. We'll just treat Thursday as a review day for anyone who wants to come. If no one shows up, I'll sit in this classroom and I'll work on some stuff. I'll grade. Questions? Do you think either of you are going to show up Thursday? Maybe? No pressure. You really don't have to if you're doing good. But if I don't see you Thursday, it's probably the last time I will see you. So it was good having you two in class. For everybody watching, it was a good semester. Take it easy. Yeah, I'll see